began this webinar series with this group of crop growers because we noticed the value of peer learning and how farmers were learning from each other. A key aspect with this group of farmers is that they've all come together for the same reason. They're all interested in the same types of innovations for their cropping practices. In each of these webinars, we cover a lot of practical information. And to help you navigate the content easily, we've created chapters in the description of the video on YouTube. If you're watching this on our website, first, make sure to click on the YouTube logo in the bottom right corner. And then click Show More in the description to reveal the chapters. This webinar focused on a new tool to help farmers easily record and monitor some key indicators of soil health on their farms. The first part of this video features a demonstration of the Soilmentor phone app, followed by some analysis of participants' data by agroecologist Nicole Masters, who provides some practical insights. Well, we're so lucky to have Nicole with us. I'm not going to try to introduce you, Nicole. Can you introduce yourself?
Thank you, James. Thanks for the invitation. International Woman of Mystery is how I'm introducing myself these days. So I'm an agroecologist. I'm currently based in Montana, originally from New Zealand. These days I've moved away from coaching and consultancy to training the coaches, so training other agroecologists to go out and work with producers. Through our programs, we're currently working alongside organizations that manage over 29 million acres. It might be a little bit higher. So yeah, feel like we really are seeing some extraordinary uptake on the ground. Part of the reason that I'm here today is I reached out to Abby, maybe Abby reached to me, I can't remember. We had a consultant level app that we were using that was just a little glitchy, and we worked together to try and create something that would be more user-friendly for producers, as well as being able to gain information from for a consultant level investigation into soil health. So Vidacycle, Abby and I have been working together for quite some time. So great to see it on the ground. We're very excited. We're actually currently putting it into Spanish and seeing it being released in South America, which is great.
So on our website, which is soils.vidacycle.com, if you go to the soil tests page, here you'll find the Regen indicators. So again, it was Nicole Masters and her team at Integrity Soils who defined these 10 Regen indicators. They're the things that Nicole and her team deemed were the most important things to look at in order for you to understand what's really going on in your context. Today, I'm going to just hone in on the 4 of those that we're going to focus on in the month ahead. So I thought I'd start with rooting depth, 80%. So this is something that I'm just going to click on it. And here you can see there is actually information about how to do the test. Here we're looking at, where does 80% of your rooting biomass get to below the ground, essentially. You just need a tape measure for this one and a spade. I mean, obviously, the idea that you're going to determine where exactly 80% of the plant roots reach, it's an approximation on some level. So as you dig the hole and you put your tape measure in there and you record where your 80% rooting depth is, you want to take a photo with the app. And a key thing to understand about the way Soilmentor and the Regen platform works is that the phone app itself is actually just for taking observations in the field. And it does work completely offline. So it's not for doing any analysis, really. It's just there to help you as you're out and about recording those things on the go. The fun bit is actually on the computer. So if we go into the area where it says soil samples, here you can see a number of samples have been added at this site. We've actually already added some GPS locations for these samples as well. So I'm just going to go look in the map view and I can see these GPS locations. And I'm going to click on one of them with these tests, you want to set a location because you're going to go back to that location again and again to kind of get your sense of how things are changing. That's the way it works. You set up a transect and you come back year after year, month after month, week after week, however frequently you're doing them. So in the next month, we want to have, maybe you can set up 2 set transect sites or 1 in each of your fields. And then you can go back to them. We'll go at least once and maybe twice in the next month. Anyway, so if I go into the sample site, here you'll see we've got the Regen indicators as a drop down. We want to go in there. And if we just scroll down, you can see here that it says rooting depth 80%. Click on that. And here you're able to enter a value. So one thing I just wanted to highlight is I showed you the description of how to do the test before on the website, but actually that description is in the app with you in the field. So if you just, next to where it says rooting depth 80%, there's that little green I button. If you click on that, it brings up all that information I just showed you. So if you were in doubt or you wanted to recheck on anything, again, this is all written by Nicole and her team. Here it says, dig out a section with a ruler, judge the 80% of roots and record that number in the app. So let's say we've got maybe to 15 centimeters, we've got 80%. And if you want to take a photo, which I would highly advise, so here in just above the save button, you can see there's a little camera. If you click on that, that brings up a photo screen. I'm sorry, I'm clearly not in a field. So I don't have any roots, but I do have a plant. So we'll take a photo of the plant. And you just say use photo. And then you can actually take multiple photos as well. And if you want to make some notes as well, you just click on the notes section and say plant. Okay. And then I'm just going to scroll. And then once I've entered the information I want, if I just click on the purple save button, sorry, that's now all saved. And if you wanted to check that, at the top, there's a tab bar and it says add history details map. If I click on history, it will show me all the information I've ever recorded at this site. And at the top there, you can see it says rooting depth 80%. And has a photo. And if I click on that, I can see everything I just entered. And I can also update it. So if I actually got it wrong and it was 16 centimeters, I can just click on it, update it, and then click the update button. And that will now save as 16. Like these numbers, I'll show you, the Regen dashboard is going to help you. And they are amazing for providing you with some more concrete analysis that you can then compare with others and get trends from. But obviously, as every farmer knows, like the observations and the context are hugely important to enrich those numbers that come out. So definitely, I couldn't encourage you more to make as many notes as you need to and take as many photos as you want, and really make sure the data is rich for your, that's for your help as well. So that when you look back, you're like, oh yeah, that was what it was, the situation then. But also when we're talking to Nicole, the more she can see in that moment, the easier it will be for her to make assessments. Okay, so
that sounds really good. So just a quick thing. So you push your spade in and then you lift it out, or do you kind of just pull it away a little bit?
Yeah, so normally we would encourage people to when you go and dig the hole, you dig 3 sides with the spade. So put in the 3 cuts of around a spade's width square. And then if you can, if it's soft enough, on the 4th side, you don't cut it. And then you leverage out from the opposite side and pull up. And that just allows you to have a rough edge where the soil hasn't been cut by the spade, and then you get like smearing of the soil and all sorts of things. If it's possible, that's the ideal way to go and look at the profile in the whole. Okay, so the one other thing to remember about the phone app, before I go to the web app, is that all of this has been recorded offline. So actually none of it will appear on the website right now. I have to go and manually press sync for it to appear. Okay, and it is quite important to remember that. Otherwise you might think, why is my data not on the computer? So if I just go back to the home screen here where it says admin, if I click on that, drops down and there is a sync button. And if I select sync, that will then upload all of that data onto the website. So yeah, it sends all the photos and everything, and it will also draw down anything from the website. So that is a really important part of making sure that everything you've recorded is visible to you later on. So when you log in to Soilmentor online, this is what the interface looks like. I don't know if anyone has done this already or not, but yeah, this is what it looks like. And here you can see the information we just added, the 2 photos I took. And you can see you can actually get some really good quality photos in here. So what I'm going to show you now is the Regen dashboard. And this is speaking to David's point. So if I just click on here on the left-hand side where it says Regen dashboard, this is what we built with Nicole. So you can see here for each of your fields and each of your transect sites, you need to have said what your soil texture, land use, and rainfall is. And once you've set that, then it will show you for your biome, rainfall, and soil texture, as well as land use. So those 4 contexts, how good is your results, essentially. So if we go to rooting depth, 80%, here you can see a score of 10 is orange. And if I click on that, it will then tell me a lot more information about that. So here you can see on the left-hand side, we get, so this is part of that immediate feedback as opposed to trends. So here you can see immediately like a rooting depth of 10 centimeters in this context is just on the edge of being between not so good and moderate. This is all based off of scientific papers and what is considered, like in the regenerative literature, what the numbers say. And then over here, this is comparing you to others with your soil type and climate. So your peers, essentially, or people, it could be me in Chile if I have the same soil type and climate. And here you can see that 10 is actually a very average score. So although in the literature, it doesn't seem that good, actually the reality on the ground is that most people are, you're not doing that bad. There's room for improvement, but actually you're doing pretty much the same or average compared to everyone else. So what does this result mean? So this is all written by Nicole as well. And then we do, well, what actions can I take? So if I click on that, so Nicole says, this is an early warning system alert when it's in the orange. And then there's a kind of a list of considerations. So these questions are here to help you move from that observation into a place of like, okay, well, what might I do about it? It may be that, actually you just had very little rainfall this year, and that's why you think your roots aren't that deep. These questions are here to help you think about, okay, well, what might you do about improving that result? And then down here, we do have the trends over time. You can start to see how this changes, and that then plots here, although that won't be probably relevant in the next month. And then each indicator on its own is not enough to give you a proper insight. And I'm sure you all know that. So you want to do a number of indicators to give you that rich idea of what's actually happening across the board. So I'm going to look at 3 other indicators that we have chosen that we think will be really good to do in the next month. And those will be nodulation, legume nodulation, Rhizosheaths, and then the Slake test, or wet aggregate stability. So I'm going to jump into those and go through them on the app. And we can talk a bit about how to do each of those. I probably won't go through this whole process on each of them, but hopefully people feel kind of clear about how you can kind of go out and do your observations and then come to the website and learn from those observations. So I'm going to dig into the others. David, I don't know, do you have some samples there for legume nodulation, Rhizosheath, and Slake test, or any of those? Oops.
Yes, I have, Abby. So one
Great.
legume plant I've got
Great.
is faba beans. We can see some nodulation. I wouldn't say it's wonderful, but it's not too bad. So I'm sure everybody here knows about nodulation. Is there anything do you want to go through that?
Yeah, I can't, because of the light, I can't see it that well, but I'll just go through how the test works, and maybe people can chime in, and yeah, let me know if they disagree or agree with anything.
We could get David, even if we can't see it because the light's a bit low, we could get David to make an assessment based on the description that you read out.
Okay, great. Yeah, perfect. Nice, James. Okay, so if we go into nodulation of legumes here, so we've just dug up this legume and we're looking at its roots. If I look in the description, so nodules are the swollen lumps that are formed on the roots of legumes. I'm sure you all know this. And so we have a scoring system here, which goes from 0 to 2. So if I go back and I say, okay, I'm going to click where it says select option. I'm going to scroll down and go for 1.5 nodules across the root profile. And then I might make some notes and take some photos again, and then I'll save that. And that data is now recorded.
So with that one, it would be good to take a picture of the root showing the nodules, and then maybe another picture of one of the nodules that you've smashed or cut open, indicating the
For
color.
sure.
Yeah.
Absolutely. Yeah. So Rhizosheaths. I feel like I learned about Rhizosheaths from Christine Jones. Down here, because they're less well known, there is a bit of an explanation of Rhizosheaths. And one of the things to recognize is that some cultivars in the Brassica, allium, and asparagus family do not form Rhizosheaths. So when you are going and doing an assessment, maybe try not to assess a Brassica, allium, or asparagus, because you'll get a bad result. Unfairly bad result. I definitely learned a lot and noticed that Rhizosheaths are one of the first things to change, and one of the early indicators in a system of how well my crop is doing, or how well the soil is interacting with the biology. I mean, the soil is interacting with the plant. So it's a very easy thing to assess. And here the score we're looking at is just 0, 1, or 2. So again, with Nicole, this was the scoring system that she and her team use. This is a very beautiful Rhizosheath that I saw on a friend's farm here in the UK. Yeah, you can just see, like, to me, this is what a Rhizosheath is about. It's showing you that the plant is in communication with the soil. Like, and here it's just so obvious, like that stickiness is very, very visible there. And that's what you're looking for in a Rhizosheath, right? Because when you pull a plant out of the ground, it's always going to have some soil on the roots. Well, hopefully always. But if you shake it quite vigorously, we're looking for what soil is really stuck to the roots, like with a glue, essentially. And that's what you can see here, is like this is a gluey coating, which is what a Rhizosheath really is. So the last indicator that we wanted to look at is the Slake test. So again, from what I understood, many of you will have already done a wet aggregate stability test before. So that's just here down where it says Slake test, so 3 down from Rhizosheaths. And if I click on the information button here, so we can see the scoring, but if I just go a little bit lower, essentially the way to do this is when you dig your hole, you want to collect, here it suggests taking it back and drying it out, but we agreed that we're not going to do that in this case. So you can just do the test in the field. So you'll need a little bowl and some water with you. And the idea is to collect a, where does it say here? Okay, yeah, a 1. So we were talking about doing a 1/2 of a centimeter or 1 to 3 millimeter sized little piece of soil. So very, very small, right? Because we're trying to look at the size of the soil aggregate. How does it hold up in water? Yeah, thanks, James. Very small little piece of soil. And we're going to put that in the water and then start the timer for 5 minutes. Start a timer on your phone and just see how that piece of soil breaks down or doesn't in the water.
After the demonstration of the Soilmentor app, participants recorded some data over the next month for Nicole to provide some feedback and insights. The way we're going to run the session is we're going to go through the data about 3 different farms, the observations that they've put in to the Soilmentor app, and we're going to hear from those farmers a little bit about the paddock or the field where they've made the observations in the first instance. Are you right to give us a short overview there, Terry?
We're in a fairly white silicious sand that over the years has been clayed with some method or other to try and overcome water repellents and add a bit of life to the soil. Cation exchange capacity is sort of down around that 2s and 3s. So it's pretty what I call inert soil, but some people might call it sleepy soil. Well, one of the problems I see is that in these cold, wet winters, middle of June through to perhaps the end of July, soil temperatures around 10 degrees, a bit more, a bit less. And if we have it wet, it gets pretty well fully saturated. Doesn't get waterlogged, but it's fairly full of water. And all the biology just kind of just stops. And there's somewhere I've made mention that in the biometer, we did a test a few weeks ago, and the bacteria was around the 300s and the fungi was coming in at 0. So not a lot of life happening in the soil unless we put either nitrogen and sulfur on. We've been using a lot of chemical, and when I got to 65, I retired from chemical farming and trying to do it better, using some more regenerative measures and transitioning. So yeah, there's plenty of challenges there in that sandy soil.
That's great, Terry. Victoria, can you open up the trending page? So the dashboard looks at what is your soil type and then what is the biome, and then trending that against what do we see in other areas with similar biome and similar soil type. So your carbon stocks are pretty low. Can you recall what percentage?
Probably around the 0.6, 0.7, I'd say.
Yeah.
Organic carbon. And the more nitrogen, artificial nitrogen we put on in the last 15 years has just sucked out any bits of carbon that we might try to increase.
Victoria, if you can flick to the page that's got the images, and let's take a look at what Terry's seeing. So when we looked at rooting depths, one of the things you want to look at when you're thinking about 80, where is 80%? When I'm assessing 80%, I'm really looking at where is the bulk of that root mass. So we're going to get roots obviously extending much further through that profile, especially in sands. They're going to be looking for moisture, cooler environment obviously too. Then I would say that 80% really is where that break off is. So how deep do you think that is, Terry?
100 mil.
We often do see Rhizosheath development showing up clearer in sandy soils. It's easy for that sand to kind of stick to those rooting systems, but we do also see them in clay and loam soil. So great to see these roots have that Rhizosheath on them, and it's part of, if we're thinking about driving carbon down into the soil, that's not because of, how much we've trampled or how much compost or material that's been added to the surface, but how much of these exudates and photosynthetic byproducts can we be pumping deeper down in the soil. And we've seen some really extraordinary things in Western Australia. I've got some images where you can see it looks like the soil's literally bleeding with dark lines running through that soil of soil carbon that's being deposited. So it's something to take a look at, is to consider what's putting a drag on the system right now for optimal photosynthesis. Did you take a Brix test? I didn't see that.
Brix this year have been coming in about between 6 and 8. Now the sun's started to shine. We've got getting a few up to 10s and 13s.
Nice. There is another image in here. The Rhizosheath. If you just take a look at that. What is this plant?
That's sweet. One thing I do find, Nicole, is that coming up to, say, mid-June, when the plant is growing, we can get healthier roots going further, like the 80% might be a little bit deeper.
Yeah.
And then when it's wet and cold, it almost looks like get pruned.
Yeah, and they literally are being pruned through this process. And this is where it's so critical to be looking at some of your trace elements. So boron, if we think about boron specifically, boron is really held in that organic matter portion of the soil. So when we're low carbon, you'll often see potentially low boron. And again, I haven't got your soil tests here, but thinking about the role of trace elements in keeping that Brix up, being able to keep root development happening. So, you do know what your boron is?
Yeah, there is a slide there with soil tests.
Oh, Victoria, if you can just flick to that. We do have an image of Terry's test. So the one that says EAL.
Yep.
Yeah, it's 2.8, 3.9, and infrared 2.
Which is not out of control. It's that's not as deficient as what you could expect to see on a sandy soil.
So perhaps boron isn't a standout issue, but calcium is.
Yeah.
And magnesium.
Fungi are what make calcium really available to a crop. We're going to see lower calcium mobility when things are very dry. But think calcium is every single cell wall structure, like our own bodies, the bones and the teeth. What are the different mechanisms you can use to lift calcium? Because everything bounces off calcium. Think about sap pH if you were to use any of those meters. In the platform, we do have the ability to enter if you have sap pH or sap EC in there as well, and just kind of look at trending those changes over time. But that sap pH number can be critical when we're thinking about production and resilience to changes in temperature. And I think probably your phosphorus is low. Would that be right?
Definitely.
Phosphorus is really one of our main rooting elements. And it's a chicken and egg situation, because when you're low organic matter, then your soils fluctuate in temperature. They're going to get colder faster and hold on to that cold, and then they can get hotter faster and also hold on to heat. So we have these issues when we have very low soil organic matter and soil carbon, and then that ties into, that's what's holding your phosphorus, that's what's holding your trace elements. And so, like I said, it's a chicken and egg situation, because they can escalate. And this is the challenge and the hump that we kind of need to get over, so that we can get away from drip feeding plants and enable these plants to do it themselves.
So we've been applying liquid calcium, and there is a hole that I've dug down 18 inches.
Yeah.
We've got some vetch roots going down that depth.
8, did you say 80?
18 inches down.
18. Wow. Yeah, fantastic.
So there is a photo there that I'll put in.
That's positive.
Yeah. So what you're saying, Nicole, is that calcium is probably the first thing we really tried to address?
It sounds like it without kind of seeing the whole picture.
Are you on the road yet?
So yeah, we're not seeing a density of roots. So they did some work. It was really interesting in Saskatchewan and Canada, and they found underneath like an annual wheat system, they had 2,900 kilograms of root material per hectare under the ground. But then when they looked at a perennial fescue, native fescue system, they found it had 36,000 kilograms of root mass under the soil. So really thinking, okay, what are some of the species that potentially could be helping to, drive some of that root mass, that root material down there? I mean, vetch has, these little fairly spindly roots. You've got nodulation though, they're just small, is that right? And were they pink? If you go to the nodule picture, Victoria, and did you cut them with your fingers? Were they pink?
Yeah.
Good.
They're starting to sort of, I'd say dry out a bit. So when the plant was flourishing, they were pink, no worries this year.
Yeah, fantastic. And so vetch isn't necessarily giving up its nitrogen around it. That's going to happen when something's harvesting it or eating and pooping it out if you've got livestock. But there's an interesting relationship with mycorrhizae, so they can actually transport nitrogen from plant to plant through their mycorrhizal connections. The fact that you have pink nodules is a good sign in terms of trace elements like molybdenum and cobalt. So when we're thinking of nitrogen fixation and nitrogen not working as well as it could, having those trace elements functional is essential for the free living nitrogen fixers that will be living in that soil environment. And, again, having organic matter, having a place, a home for them to live, making sure that we're feeding them. And I think it kind of feeds in, Terry, you actually put some questions in the Excel sheet that came through asking about your undesirable, I guess, shall we call them, plants that are growing. So you've got some cape weed, wild turnip, marshmallow, sorrel, wild oats, heliotrope, fleabane, caltrop. Pretty much all of these are your calcium indicators as well. A lot of our indicator species are calcium and low fungal activity. So think, primitive soils, very bacterial dominated. And then, when I think about chemical use, when is my timing, and then addressing why are we seeing these weeds at all? So it might be, using calcium in your program. It might be thinking, okay, I really need to be driving this more fungal. What kind of actions can I take? So thinking about your environment, what kind of activities could you take that are going to help to lift fungal biomass?
Yep. Nicole, I'd like to suggest that we
move on.
Yes. And some of the stuff we might come back to at the end of the session.
Yeah.
The next property or observation that we're going to look at is made by Renee at Tarley Orchard. Forgive me if I've pronounced it incorrectly, Renee.
We're on a certified biodynamic stone fruit orchard, and has been that way for about 20 years or so now, meaning that we haven't applied any fertilizers at all throughout the orchard. And pretty much the main one that I was chatting with David about is a section of the orchard which is just really non-productive, and 100 meters down the hillside or east of it sort of thing, the soils are quite a lot better. It's very high calcium, we've got a lot of limestone here. And it's just really shallow soils in that section of the orchard, which is really poor. And then we've sowed a cover crop this year on that site to see if that can increase the organic matter in the soil.
So what are the main things that you can pick up that were different?
The infiltration rate was a lot slower. It was a lot more compact. And overall, just had a lot less ground cover, a lot less species growing there.
Victoria, can you show us the images?
Yes.
Let's start with the slaking test. Orchard site 1. So when we do the slaking test, it's worthwhile finding some soil that doesn't have a whole lot of root material in it. We don't need to use large amounts of soil. So if you look just in the bottom left, you can see those other crumbs. So what we're trying to look for is, does that lump stay intact? Is that water clear? Which this water is pretty clear, which is a really good sign. You know, and for those of you that have got sandy soils, what you might find is those grains can just kind of collapse, but you're not necessarily going to get a discoloration if there's low organic matter. But anytime we're seeing soils collapse, and you see that cloudiness on the aggregate on that bottom left, then this is contributing to soil losses. So often we don't realize that we're losing soil and losing organic matter.
I doubt we'd be losing soil on this side. I think it'd be pretty stable. And certainly some of the other analysis I did for Renee just showed very low available phosphorus level. So that's using Colwell and DGT phosphorus. And I think one of the big questions for Renee, and probably for a number of other people on this link, is how do we, or what's the best form of phosphorus to use in these highly calcareous soils?
Yeah, and it's a good question, and it's important. We all, I think you probably all understand the relationship between phosphorus and calcium in terms of locking up and not being readily plant available. And this is really where your microbial workforce come to action, because it's fungi and more specifically mycorrhizae. So the fungus that's in those plant roots, that really is the one that's able to break those bonds and then make that phosphorus available to the plant.
Things that I noticed out in the orchard is that, there's certain sections with really dark green and just really thick grass growth and clover growth, and that's just where the like mushrooms. So would that be something to do with them sort of letting the calcium be available?
Perfect. Yeah, that's a really good observation, and it's exactly what they are doing. So they release some very powerful acids, and it's those acids that enable them to extract and release that phosphorus. And so often what we're seeing in phosphorus limiting environments is that we can still see phosphorus coming through into the plants if we are addressing why are the fungi not as active as they could be.
No, this was I did a section where there was a mushroom ring, and then just next to it where there weren't any mushrooms, and did a bit of a comparison to see. So I mean, I didn't do any chemical analysis or anything. This is just a Regen indicators.
Oh, that's cool. Victoria, do you want to go back then and just look at that trending? I hadn't picked up on that. So that
the dashboard or the trend?
Yeah, the dashboard.
Great. Perfect.
Okay, so we're still not seeing a lot of rooting depth. You found worms though.
Yeah, so many.
Yeah. Well, 4 can start an army, if we can start to look at what's been limiting. Why are they attracted to those areas that do have those mushroom? And in part, it will be biological activity. So worms can really feel microbes vibrating. Like they only have one sense, and that sense is a sense of feel. So they can feel the vibration of bacteria, they can feel changes in temperature in the soil, and they will actually move towards activity. So if there's more activity happening in a zone, then that will actually ring the dinner bell for the worms, because they are eating your microbiology. So that's kind of interesting to see worms in there when you don't have them in other places. Yeah. And what I really like is the amount of photos that you have taken. I think we have a tendency to not take enough images. I know I've certainly done that for myself, and you go back and go, oh gosh, I wish I had more images to kind of show this. But what's interesting to me is just to see these really stunted root systems. If you look at what's growing underneath those quince trees, beautiful. And this is such a fun thing to do, is to actually dig through what we call the fairy rings. And you'll see the fungal hyphae like that. So these are saprophytic fungi. They're different from your mycorrhizae. What saprophytes do is they're breaking down some kind of organic material. But you'll see this is one organism, and you see them growing in circles in your fields, and there'll be mushrooms on the edge of that circle at certain times, which is the fruiting bodies. But yeah, to dig through it is really fun. I like to do this with kids. You can smell it. Yeah, Renee, did it smell like?
Yeah.
Mushrooms? Yeah. But where we see that growth, and you could actually send in a sample, and what you'll find is where that ring is, and you see that darkening growth. That's what your whole property could look like if you had active fungi throughout your fields. And when we're thinking about orchard systems, they should be very, very, very fungal dominant. Yeah, so thinking, all right, I wonder what happened here, what's different here than it is in that area that you're not seeing a lot of production. If you go back, Victoria, and Renee, if you can pick out which image is the area with some soil that is the least productive area that you're talking.
So that was coming out of summer when it was really dry and not looking too flush at all.
We seem to have very low levels of calcium in soils with limestone or high calcium carbonate. So how do we rectify that?
It's so interesting to me, and it's something we see a lot of. Like I've seen this in New Zealand and in the UK, is limestone soils that are calcium deficient. And really we are talking about function. So thinking of this role of fungi in these environments. And like Renee just showed that image, I think if you did some testing in there, you'd probably find that those plants have adequate calcium. One way to tell is when you're getting enough calcium is the plants will feel very soft, like their structure changes, like grasses will feel very soft. You're not going to get that coarse sensation, and you'll see the plant community change, right, as calcium becomes mobilized. But the game really is how do I lift functional calcium and or functional fungi, and a big part of that is thinking about what kind of foods. And this is why I'm such a big fan of things like humates, and this is why being able to do some trials or some trial strips, and then use the platform to take a look and see, are we starting to build more aggregate structure? Are we starting to see a density of those root systems and deeper roots? And the only way you're going to know that is really by digging some holes.
Steve has asked about the impact of they've had to put out quite a bit of fungicide this year with the rain during this time of the crop. What's the impact there on the soil fungi?
So we find some chemicals have more of an impact on beneficial fungi than others. It seems intuitive that a fungicide is going to have a negative impact on soil fungi, but the research seems to be a little all over the place on this one. I do think, and this is the chicken and egg thing too, is that we need mobile calcium to the plant for plant defenses. We need good, depends on what the crop is, right? You might need good zinc or copper. There's a book I always recommend, which is Don Huber's one on mineral nutrition and plant diseases, to think about what is causing these fungal diseases. Is it a trace element? Is it low calcium mobility? And then addressing it while we're doing fungicides. So trying to look at how do I wean off. I know you guys probably had a lot of moisture, but with low functional calcium, you're going to have more issues with fungal diseases. So looking at how to address that and reduce those fungicides. So yes, the research is a little non-conclusive. You can, there are some resources online that'll tell you which chemical seems to have more of a negative impact. And so maybe looking at an alternative chemical or even some of the organic fungicides to transition while you're building nutrition would be a good start. But yeah, good question.
So Scott, whilst Victoria's bringing up the data for your observations, can you tell us a little bit about what's been happening in this paddock?
What's been happening? I've got a few paddocks there that I've tested. but we kind of go down about 10 centimeters and then hit a hard pan. So whether it's a clay or a buckshot soil, yeah, the roots kind of hit that, and that's pretty well where they kind of stop. Yeah, David's done some soil tests out at my place. Also, I didn't put any of them up, but yeah, so we seem to have a lot of capeweed and stuff to grow. Is one of the major ones on our place that grows. Also in our pastures, we've got a lot of barley grass and Kingston grass that seem to have taken over. So just wondering if a lot of that's to do with compaction and how we can get away from that. We had a hay cut paddock that we cut the hay. I haven't got any pictures of it, but the top of the soil was full of worm activity. So we've got worms. I've been using a fertilizer which has a lot of biological stuff around it, carbon and stuff, to buffer it, which seems to be working well. And I have noticed on my farm, my salt country, which is normally really dead, has actually come alive, and there's a lot of grass, even though it's been really a wet year.
So Scott, it says, I'm looking at the table here, it says that you were using green rye biological inoculant for legumes, is that right?
That is right, and I found that yeah, that worked really well and had good results with my inoculations with it. So it's something that I'm going to definitely move towards. Talk to the guy who creates it, and he is making stuff up for pastures with clover bases so that you can spray it on before the start of the year to increase your nodulation if the levels are low.
And do you see a difference when you're looking at these different visual assessments, or did you see something above ground, or did you treat every part?
So I treated all my beans, but I actually saw nodules on, I think I've got a picture of the beans up there, nodules even on the really fine roots, which normally you only see them on the big main roots, but they were over the small roots as well.
Just fantastic. And it's a good one for people to see, because often you might find you have a couple of nodules on some lateral roots. So those are the ones coming off to the side, and they can be quite small, but these are just dense and large. It's pretty cool. And again, it depends on the species that you're looking at, right? So different species will have different nodules, and you can see without even pinching these that these are pink, right? Well, that's a pretty good sign, I guess, from putting your inoculant in. Did you notice that there was then a difference in production or any other feature?
They're actually growing really, really well. Like they're probably nearly up to 6 feet high, the beans.
Wow.
So I had been using a dry inoculant the last few years, putting that down with my beans, and I had seen no inoculation like this at all, whereas this one was a easy one. You put it on the seed and actually dried really well, and it didn't block up the air seeder, and it was a really good product. I think the guys in Adelaide who produces it. So yeah, it's a good local product, and I'm just amazed at how it's worked. So looking forward to the wheat crop on it next year and how that responds.
Oh, so it's not just a legume inoculant?
It is a legume inoculant, but this guy has actually also developed a one for cereals that he reckons works at about 15%.
Is there a picture of where that came out of the soil? Yeah, so we have got soil sticking to those roots, which is a good sign. We have that crumb structure, as your aggregates are forming. It looks like it does get harder further down. Is that right?
Yeah, it does. By the time you get to the bottom of the spade, yeah, it gets really hard. So just wondering how to get that level to kind of break up.
Yeah, and I think by having nodules and root systems like this is certainly going to help. Did David, with the testing, did you identify what was causing that hard pan? Is that a mineral hard pan?
Look, it's a combination of three things, Nicole, varies depending on the site. some of it's just machinery compaction. So also there on these soils, we have a range of different aggregate sizes, ranging from sand, silt into clay. And on some of these soils, they appear to naturally compact because you have almost a cementing effect occurring by the chemistry. And because the organic carbon levels are low, it's a bit of a chicken and egg thing. Low organic carbon levels means that these soils don't have the binding agents to aggregate them. And certainly listening to some other discussions, the best results we get on these soils is to actually run some steel through them and then change to controlled traffic, but also those different species mixes to increase that biological function. But we may have to open the soils up first.
Yes, and I think there's a time and a place for a bit of steel. But thinking often these issues have been because of some kind of biological breakdown. So thinking, do I address an issue mechanically when it's a biological issue? And if I'm going to address it mechanically, then can we put some kind of biological foods down this? So quite a few people I work with in Australia have adapted their rippers or discs even to just drip something down behind it. And it could be just a little bit of molasses. It could be a bit of liquid sugar. It could be some of these humic products, just to ensure that these things don't seal up again, because they have a tendency to do that. And then thinking about what are some of the deeper rooting species that maybe we could look at that are going to help to get down and through and keep those open. If it is something like a low calcium, high magnesium, even high iron, this is where we might use a little bit of gypsum. And so a liquid, like putting gypsum into a liquid form and putting that down the drill, or even putting that below the seed. And I've seen some extraordinary results where we're putting like 25 pounds of gypsum, so 25 kilos, of gypsum, and 30 kilos of like a humate, raw humate, and we're putting that down below the seed. And then that just helps to flocculate, which is literally, open up, form aggregation beneath the plant as it's germinating and that root's getting down. And then that plant itself can drive and keep that those compacted zones open. And we've seen roots being able to get through these systems within about 6 weeks using an approach like that. So sometimes if we are seeing these layers, you want to go, okay, what's causing it? So if you identify it as machinery, and it's not necessarily machinery, but it might be that you're operating when soils are a little bit too wet. Low organic matter is going to cause compaction, like David said, and an imbalance with your calcium, magnesium. High potassium can do it. And then obviously if we've got sodic soils, that's going to disperse and cause issues with soil structure. So asking the question of why is it that this is happening, and then addressing it by addressing that issue, rather than just thinking a cover crop's going to do it, or just biology is going to do it, or just ripping it's going to do it. Like really approaching it from all those different angles to get through that. It's a great start, because those roots are going to be pumping a lot more exudates out to actually help to address some of these compaction zones. And again, that's why trending this over time and looking at where is that layer. So the property I was living on in New Zealand, we had a calcium silicate loess, and you can buy this calcium silicate to quick set concrete. And we broke through that without the use of any mechanical interventions, but it took us 7 years, right? So I'm not saying it was a super easy process, but we decided not to mechanically intervene and instead address it using some of the deep tap rooted species. Like, I think some of you know, I'm a big fan of chicory. So getting chicory in there, some of those radish species, but things that are going to really help to break that open.
Yes, we do. Yep, that's correct. So one of the ones, I did a soil test on the pastures as well as the wheat, which was across the fence.
There you go.
Yes, thank you. So Scott, this kind of reflects what you see when you dig it in the shovel. That's where the shovel gets hard.
Yeah. Especially in this pasture, I was surprised because it's been in a pasture phase for probably nearly 7 or 8 years. We're probably 6 years where we haven't used many chemicals at all, and just sowed straight into it. Use slashing to try and control the grasses. But yeah, I was really surprised about how hard the soil was. So whether that is actually more a stocking thing, because it's been set stock for a fair while, on and off, that compaction's happened. And also this year we've had a really good clover grow in our
pastures.
It looks
amazing.
But the nodulation on it wasn't actually very much, but compared to the beans anyway.
Yeah, and I mean they do have smaller nodules anyway, but you see the root systems are not very well developed, and you can't really see very good nodules in that. So thinking about impact from livestock, we have what I call the cow pan, and that cow pan is kind of that top inch. So when we set stock, we may be causing compaction that's not necessarily from animal treading, but because of the impact that overstocking has or overgrazing has on root formation. So instead of deepening those root systems and really getting through those compacted zones, when we overgraze, those root systems will shrink. And we see that is not helping to break through that compaction lower down, but it's not causing that compaction on that top surface, which I think is good. It might point more to stocking rate rather than how long animals are in a pasture. But really thinking, okay, how do I graze for optimal underground root development? And some of this recovery that we talk about with grazing is, are we digging a hole to see if the roots are recovered? And sometimes what we find is people are coming in, bringing livestock in before the plants actually have recovered, and still seeing that your root systems are only an inch or two from the surface, which also means that, we haven't got a lot of resilience when it dries out.
Yeah, so we can see the soil is alive. It's just, sometimes we have to try and control red-legged earth mite. So trying to do that without killing everything underneath.
Yeah, and thinking about your red-legged earth mite, these things are suckers, sap suckers. So anytime we're dealing with sap suckers, we're talking about plants that generally have a lower Brix, lower complex carbohydrates, what we call incomplete proteins, which is also what your capeweed is pointing to. So capeweed and red-legged earth mite are the same soil pattern in terms of indicators. So rather than using an insecticide, thinking what can I do nutritionally, and you can just do small plots and spray different things, and it could be like a small amount of molasses, again, a small amount of humic. What's going to actually lift my Brix and turn that into a food that's no longer suitable for red-legged earth mite. There are some biologicals for and I don't know how readily available these are, but a product called Metarhizium, it's a fungus that will specifically target insects that are chewing on the plant. I'll spell it, and then if anyone wants to go and have a look and see what you can find. We actually have a company not far from where I'm living here in Montana that's actually making this particular fungus. And it's a selective fungus. It's very selective in terms of it gets inside the plant. It'll live like an endophyte, like a mycorrhizae, and then it targets what's chewing. So some of you, I can see there was some weevil damage. I've seen some root chewing insects in some of your pictures, like clover weevils and things. It's very specific to those kind of pests. So that might be an interim to just take a look at, is, okay, what are some of the other options apart from insecticides? And again, nutrition is key. Yeah, I've got some images here that are phenomenal. It's not red-legged earth mite, but they're aphids. And just through they applied 40 litres of a worm extract tea with half a litre of molasses, and within 3 days the aphids just died. Like, they literally were popping, and the Brix went from 3 to 18. And that's not due to the molasses, right? It's I'll show you these pictures because it's pretty cool. So this is the aphids on those leaves, and then this is 3 days later. That's all their bodies just on the bottom. Just yeah. So that's pre-application and post-application. So, you know, if you just set up some small trials for yourself and find different ways to monitor, and it is why we like the Regen platform to be monitoring changes underground. But, you know, just set up small plot trials, and it sounds like quite a few of you are doing that, which is really cool.
Thanks very much to all of our speakers and webinar participants. So much learning comes from the group interaction with questions and answers. Thanks also to the Australian Government's Future Drought Fund for supporting this webinar series. You can find more resources about this and other webinars in the description of this video below. We would love to run more of these events, and if you would like to become part of our growing farmer community, join our social media pages and subscribe to our newsletter to hear about the next opportunity.